Hello and welcome to SS Section 1 Math. Today we'll be teaching you, yes you, all about Chapter 7, which is about right triangle. Not wrong, that's right, right triangles. Now, right triangles are clearly everywhere. Somewhere here. But how do you know if a triangle is actually right? Now some say you can just draw a little square in the corner and that means it's right. But we'll be showing you an innovative converse theorem to show you how to find out if a triangle is right.
To prove the Pythagorean theorem, we're going to show you an informal proof. As you can see in the diagram, there are 4 right triangles in the corners that are all congruent. They also form a smaller square in between. Because of this, you can see that the area of the larger square will be equal to the area of the 4 triangles and the area of the smaller square that they form in between. When you put this in an equation, you're going to get a plus b squared is equal to 4 1/2 ab plus c squared, where a plus b squared is the area of the entire square, and 4 1/2 ab plus c squared are the areas of the 4 triangles and the square in between. When you simplify this, you're going to get a squared plus 2ab plus b squared is equal to 2ab plus c squared. Take out the 2ab and you're going to get a squared plus b squared equals c squared, and this is the Pythagorean theorem. But who created this theorem?
Who's that mathematician? It's Pythagoras!
But how to use this theorem? You can use it to find the missing lengths of a right triangle. Let's use a Pythagorean triple for this example. To use the Pythagorean theorem, which is a squared plus b squared equals c squared, let's assign these variables some values. A will be 3, b will be 4, and c will be x. Substitute these values into the equation and you'll get 3 squared plus 4 squared equals c squared, which is 9 plus 16 is equal to c squared. This is equal to 25 is equal to c squared, and find the square root of 25, which is 5. So c is equal to 5. Do the same thing with the second triangle. A will be 5, b will be 12, and c will be x. Put these into the equation and you'll get 5 squared plus 12 squared is equal to c squared. This is equal to 25 plus 144 is equal to 169, which is c squared. Find the square root of 169, and which is going to be 13, so c equals 13. These are called Pythagorean triples. This one is a 3, 4, 5. The second triangle is a 5, 12, 13. And other triples include the 7, 24, 25, and the 8, 15, 17. Other triples also include their multiples and other numbers that are not whole.
You can use a protractor to see if a triangle is 90 degrees, but that's overrated. But wait, there's more!
Wait, what?
So, Pythagoras was actually a real genius, and his theorem could actually prove if a triangle is going to be obtuse or acute.
So here we have our equation. Now if c squared is greater than a squared plus b squared and make Pac-Man eat him, then we know that this triangle is going to be obtuse. Now if we draw the equation and Pac-Man is actually eating a squared plus b squared, then we know this triangle is acute. So see right here we have a less than sign, over here we have a greater than sign.
Do you ever wish you could get more right triangles out of one right triangle? Well, you can! Now this might blow your mind, but
if you draw a line from the right angle to a hypotenuse, you get even more right triangles. If you do some complex math, you would see that the 2 small right triangles and the big right triangle are all similar. Now there are some theorems that come with these right triangles. The first one is BD, which is this line, over CD, which is this line, is equal to CD over AD. Another one says that AB, which is this big line, over CB, which is this line, is equal to CB over DB, which is this line. Another similar one is AB to AC is equal to AC over AD. Now you can see that the denominator of the first fraction and the numerator of the second fraction is the same, and this can be put as A over X equals X over B, and this is called geometric means. How do you use these geometric mean theorems? Say DB is 3 and CD is 6. Now you can find the value of AD by using the theorem BD over CD equals CD over AD. Now if you put in the values, you get 3 over 6 equals 6 over x. Now you can cross multiply and you get 36 equals 3x. Now if you divide both sides by 3, you get x equals 12. So the value of AD would be 12.
What's even more special than right triangles? Special right triangles, and here we're going to take a look at them right now. So here we have a 45, 45, 90 triangle, and here's a 30, 60, 90 triangle. For the 45, 45, 90 triangle, both of the legs are x, and the hypotenuse is x root 2. If you know the length of one of the legs or the hypotenuse, you can find the length of the other legs. For the 30, 60, 90 triangle, the shortest leg is x, and the leg adjacent to that is x root 3. The hypotenuse would be 2x.
Now, Pythagoras couldn't swim, so whenever he was near a pool, all he would do was soak a toe. Now, some genius mathematician put this all down as SOHCAHTOA, although he did misspell pretty badly.
So you have SOHCAHTOA, and these stand for the sine of the angle equals the opposite side over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So for this example, you have the angle measurement of 35 and the hypotenuse of 10, and you want to find the opposite side. In this case, you want to use sine, so you do the sine of 35 equals x over 10. You can multiply both sides by 10. If you do this on a calculator, you get approximately 5.736 for x. You can also use these trig functions to find unknown angles by using the inverse sine, cosine, or tangent of the values you have. For this example, you have the hypotenuse and the opposite side of the unknown angle, so you would use inverse sine. You can use so you can do inverse sine of the opposite over hypotenuse, or 5.736 over 10 equals x. If you do this on a calculator, you get 35 for x.
Time to learn about angles of depression and angles of elevation. Now we can learn this by visiting our good friends Romeo and Juliet. Let's head over there now.
Oh triangle, oh ever so similar triangle, ever so poor proportion.
So here we have Romeo and Juliet looking at each other on the balcony. Now let's imagine there are some lines so we can see the angles they're looking at. Now using parallel lines, we can see that these two angles are congruent. Now Romeo, he's happy and excited looking at Juliet's beauty, so the angle he looks at is called the angle of elevation. Now Juliet is sad and depressed that their love is forbidden and can't happen, so the angle she looks at is called the angle of depression.
Now let's review what we learned today and solve this right triangle. To find x, you're going to use the tangent of 37, which is equal to x over 12. Multiply each side by 12, and x should come out to be approximately 9.04. Using this, you can find the measurement of the missing angle. To do this, you're going to use the inverse tangent multiplied by 12 over 9.04, because this is the opposite over adjacent sides. This should come out to be approximately 53 degrees. Now to find the length of the hypotenuse, you're going to use Pythagorean theorem. So 9.04 squared plus 12 squared is equal to x squared. This comes out to be 81.72 plus 144 is equal to 225.72. Find the square root of this and you're going to get 15.02, which is the length of the hypotenuse.
Oh